Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS School. In this video, I will discuss about linear ordinary differential equation with constant coefficients, and the equations will be of higher order and first degree, and I will use the method of D operator to solve the equations. So, what is capital D? Before telling that, I am writing the general form of linear ordinary differential equation with constant coefficients. So the general form is, here I have written higher order. I will use the second order and first degree equation. Method will be same for all the order. Maybe it is greater than 2. I am using second order equation. So the general form of second order and first degree linear ODE with constant coefficient is d square y dx square plus p1 dy dx plus p2y equal to capital X, where p1 and p2 are constants, arbitrary constants, and capital X is a function of X or a constant. So this is the general form. In the name there is a constant coefficient, so these coefficients must be constant. Okay. Now in this chapter I will use a notation capital D for the operator, and the name of the operator is differential operator. So D is the differential operator and is equivalent to ddx. That is, D means, D of some function means first order differentiation of that function with respect to x here. Okay, so D square is used to denote d square dx square, that is second order differentiation, and so on. Now if we write this equation using capital D, then we get d square y plus p1 dy plus p2y equal to capital X. Now we can see that d square plus p1d plus p2, this is operating on y in the left hand side. So this is the equation equivalent to 1. I just used the notation capital D in place of ddx or d square dx square. So to solve this type of equation, we have to know what is the general solution first. So the general solution of this type of equation are divided into two parts. One part is called CF, that is complementary function, and another part is called particular integral. In short, we call it PI. I am writing the general form of general solution. General solution is y equal to CF. Before solving, I am writing the general solution. It will be easier for you to understand, so I am writing PI. CF is complementary function. Complementary. Now I will discuss what is CF and what is PI, or how to find out. So I wrote before this complementary function, and PI is particular integral. Now for solving this type of equation, first we have to find CF and then we will find PI. So CF is obtained from the left hand side and PI is obtained from the right hand side. Okay. Now we see that there is a operator that is d square plus p1d plus p2 in the left hand side. So CF will be obtained from this operator when this is operating on y, I'll discuss the method. And since there is no operator on the right hand side, I can transfer this operator from left to right. Then after transferring to the right hand side, that function will help us to find out particular integral. So first I will discuss how to find complementary function. Okay. So to find complementary function, first we have to consider the homogeneous part of this equation. Now what is homogeneous part? Homogeneous part means we have to consider the right hand side function as 0. In the given equation it may be 0 or may not be 0. If it is non-zero, then we have to consider the right hand side function as a 0 function. So let us consider, now I am discussing how to find out complementary function. Let us consider the homogeneous part of 1, that is d square plus p1d plus p2 operating on y equal to 0. This is the homogeneous part. Next, we will take a trial solution. So let y equal to e to the power mx be the trial solution. So why this is we are taking this as a trial solution? Because this function will satisfy this equation for certain values of m. Just after some moment we can see this. We can see it. For some certain values of m, this function always satisfies this equation. Now, since we assumed that e to the power mx is a trial solution of this equation, so I am putting this function in place of y. Okay. Now, then this will be d square. Before putting, I find first dy. Dy means differentiation, first order differentiation of y, that will be m e to the power mx, and d square y will be m square e to the power mx, second order differentiation of y. Now I will put these values in this equation. I am numbering 2. Okay. Now d square of y means m square e to the power mx plus p1 dy means m e to the power mx plus p2 and y equal to e to the power mx. I have put the values of y, dy and d square y in equation number 2 equal to 0. So here we can see that e to the power mx is common. We are taking out e to the power mx, m square plus p1m plus p2 e to the power mx equal to 0. Now from here we can see that the product of two functions is 0. So any one will be 0, but we know that exponential function is always non-zero function. So m square plus p1m plus p2 will be equal to 0, since e to the power mx is not equal to 0. Now this equation, quadratic equation in M, is called auxiliary equation. This is the quadratic equation because we took a second order ODE. So the power of the degree of this equation will be equal to the power of the order of the ordinary differential equation. Here this is a quadratic equation. So this equation is called auxiliary equation. Auxiliary equation. The CF, that is complementary function, we are discussing now about complementary function. The form of the CF, what will be the complementary function of the given ODE? It will depends completely on the roots, nature of the roots of the auxiliary equation. Okay. Now I will discuss the nature of the roots, how the complementary function depends on the nature of the roots. Okay, there may be various types of roots. So let us consider one by one. Case 1. If the roots of AE means auxiliary equation. If the roots of the auxiliary equation are real and unequal, say alpha comma beta. I am assuming that the roots are alpha comma beta, which are real and unequal. Then CF will be of the form C1 e to the power alpha x plus C2 e to the power beta x, where C1, C2 are arbitrary constant. I am not writing this in the board. You remind this, C1 and C2 are arbitrary constant. If the roots are real and unequal, then CF will be of this form. Case 2, if the roots are real and equal, say alpha comma alpha, then CF will be C1 plus C2x into e to the power alpha x. If the roots are equal and real, then complementary function will be of this form, C1 plus C2x into alpha x. And the last case is the last nature of the roots. We have taken real, all the types of real roots, so the remaining nature is obviously the roots will be complex. If the roots are complex, say alpha plus minus I beta, then CF will be e to the power alpha x into C1 cos beta x plus C2 sin beta x. This is the form when the roots will be complex. Now I will show you three examples for these three types of roots. Then it will be clear to you. Okay. So these are the three sums I have written for three types of nature of roots. So one by one I will solve it. First, number 1. See, the sum is d square y dx square plus 5 dy dx plus 6y equal to 0. I have taken for all the equations the right hand side as 0 because we are finding only CF, complementary function. If it is non-zero, then also you have to consider, I have told before, the homogeneous part, that is we have to consider the right hand side as 0. Okay. Now if this is non-zero function, then we have to first write that let us consider the homogeneous part, but this is already homogeneous equation, so I am not writing that. So first step will be, we have to take the trial solution. So let y equal to e to the power mx be the trial solution. I have just shown a moment before when I took the general form of equation d square y dx square plus p1 dy dx plus p2 y equal to 0. The same steps will be followed here. Okay. We have to find dy. Just in place of p1 there is 5, in place of p2 there is 6. dy will be m e to the power mx. For the first sum I am doing all the details, for the remaining two I will step the jumps. So follow this sum minutely. d square y will be m square e to the power mx. Now I am putting first, you can write this equation using capital D. This will be d square plus 5d plus 6 operating on y equal to 0. Okay. Now we are putting these values. D square of y means m square e to the power mx plus 5 into dy. dy means m e to the power mx plus 6y. 6y equal to e to the power mx equal to 0. So e to the power mx is common. M square plus 5m plus 6 operating on e to the power mx equal to 0. Now since e to the power mx is non-zero function, therefore m square plus 5m plus 6 will be equal to 0. Okay. So this is our auxiliary equation. This is our auxiliary equation. You can write direct the auxiliary equation. It will be same of the form the d operator, as the d operator form, which d operator will be in which form. Okay, so it will be identical to d operator form. So you can write it directly, but you should do the details when you are solving a sum. Okay, now this is a quadratic equation in M. The roots will be here -2 and -3. Now see that these roots are real and unequal roots. So the CF will be of the first case. So CF will be C1 e to the power -2x plus C2 e to the power -3x. This is the complementary function. In case 1, I said that if the roots are real and unequal, so in this case the roots are real and unequal, so this is the CF. And the general solution also this, because there is no function in the right hand side, so there will be no pi particular integral, so this is the general solution. So y equal to C1, so y equal to C1 e to the power -2x plus C2 e to the power -3x. This is the general solution. Okay, now I'll solve the second sum. Now see, in the second sum, if we write the second sum using capital D, it will be d square plus 4d plus 4 operating on y equal to 0. Okay. Now we will follow the same procedure, so I am not doing the details. I said that the auxiliary, we need the auxiliary equation to find the root. So the auxiliary equation will have the same form of the d with the d operator form. So the auxiliary equation will be is m square plus 4m plus 4 equal to 0. The roots will be -2 -2. Okay. So these roots are real and equal. So we have to follow the case number 2, and in case 2 the CF was C1 plus C2x into e to the power -2x. This is the complementary function, and here this is also the general solution since the right hand side is 0. Okay, so this was for second case. And last case, number 3, I am writing the equation in using capital D, 2d plus 7, y equal to 0. So auxiliary equation will be m square plus 2m plus 7 equal to 0. Now to solve this auxiliary equation, we will have to use Sridharacharya's formula. So m equal to -b plus minus root over b square minus 4ac, that is 28 by 2a. So this will be -2 plus minus 4 minus 20 is 28 is 24 minus 24, and root over of 24 is 2 to the 4, 2 root 6, okay, into I by 2. So the roots will be -1 plus minus root 6i. So see here the roots are complex roots. So you have to apply case number 3. So I am writing here CF, or I am writing direct general solution is y equal to e to the power -x. Okay, there the case was the CF was if the roots are alpha plus minus I beta. then the CF will be e to the power alpha x. Here alpha is minus 1, the real part. So e to the power minus 1x into C1 cos beta x. Cos beta x, here beta is root 6, cos root 6x plus C2 sin root 6x. So this is the general solution. So this was the discussion how to find complementary function of a linear ODE with constant coefficient, higher order and first degree, and I used D operator method. So for finding complementary function there is no other method. This is the only method I just discussed. So you practice and find the complementary functions for various cases. Okay, in the next video I will discuss how to find particular integral. Okay, then we can solve this type of sum completely, CF plus PI. Then we will find the general solution CF plus PI, y equal to CF plus PI. Now I will show you some more example how to find complementary function. Number 1, d square plus 6d plus 9, y equal to 0. Number 2, d square plus 14d 9d plus 14, y equal to 0. And number 3, d square plus 2d plus 1 plus 6, y equal to 0. Now if I consider the first problem, in this video I just discussed how to find the auxiliary equation, and I have also gave you some examples, and you know that how to find the auxiliary equation. So I am doing here for the first example. Let us consider the homogeneous part of this equation. So since the equation has already 0 in the right hand side, so separately we will not have to consider the homogeneous part. If here there will be non-zero function, then we have to consider the homogeneous part. So here it is not needed to write this. So we have to first take the trial solution. So let y equal to e to the power mx be the trial solution. Then dy equal to m e to the power mx and d square y equal to m square e to the power mx. Now we put these values in equation number 1. So d square y will be m square e to the power mx plus 6 dy, that is m e to the power mx plus 9 y is e to the power mx equal to 0. So m square plus 6m plus 9 and e to the power mx is common. So we can write m square plus 6m plus 9 equal to 0. Since we know that e to the power mx is not equal to 0, because exponential function is always a non-zero function. So by solving this, we can write that m plus 3 whole square equal to 0. So m equal to minus 3 minus 3. That is, this is the auxiliary equation, m square plus 6m plus 9 equal to 0. And the roots of the auxiliary equation, we see that minus 3 minus 3. So the roots are real and equal. And I told you what will be the complementary function if the roots are real and equal. So here the complementary function that is equal to that is same with the general solution, since there will be no particular integral, since there is 0 in the right hand side. So the general solution is y equal to c1 plus c2x e to the power minus 3x. I have written already the rule how to write this general solution if the roots are real and equal. Okay, now we are considering equation number 2. Now this part will be same for all the sums like this. Y e to the power mx be the trial solution, and we have to find the required differentiation of y, and then we have to put the value. Now in equation number 2 there will be 9 in place of 6 and 14 in place of 9. So the auxiliary equation will be m square plus 9m plus 14. 9m plus 14 equal to 0. So this is the auxiliary equation. Now if we solve this, if we factorize this will be m plus 7 into m plus 2 equal to 0. Okay, so from here we can say that m equal to minus 2 comma minus 7. So the roots are real and unequal. Now you know what to do if the roots are real and unequal. So the general solution is y equal to c1 e to the power minus 2x plus c2 e to the power minus 7x. So this will be the general solution if the roots are real and unequal. Okay, now I'll take the third and last example. So only the auxiliary equation will be changed. Here it will be 2, here it will be 6. So the auxiliary equation will be m square plus 2m plus 6 equal to 0. Since exponential function is non-zero, since e to the power mx is not equal to 0. Now we have to solve this. We have to find the roots of this auxiliary equation applying Sridharacharya's rule. So minus b plus minus root over b square minus 24, that is 4ac by 2a. So this will be minus 2 plus minus 20i, because 4 minus 24 will be minus 20. So root over minus 20 is 20i by 2. And this is equal to minus 1 plus minus 10i. So now we see that the roots of the auxiliary equation are complex. So for complex roots, the general solution will be y equal to e to the power minus x into c1 cos 10x plus c2 sin 10x. So this is the general solution. So here I have given the examples and I have discussed how to find the complementary function for different cases. The roots may be real equal, may be real unequal, may be complex. For all cases, I have discussed how to find the complementary functions. And already I have told you that you have to practice the sums. If you face any problem, at the first of this video, a slide is given, and in that slide my contact details is given. You can contact me. Okay, so it was for linear ODE with constant coefficient and for one part of solution, that is complementary function. If there is any non-zero function in the right hand side, then we have to another find another part of the solution that is called particular integral. In next video, I will discuss about the particular integral. So this was all for this video. Thank you.